Okay, class, we're going to talk about extrinsic control. This will be B, extrinsic control B. All right, the first thing we're going to speak on is the chemical regulation of heart rate. Hormones can regulate heart rate. Neurotransmitters can. The hormones that can regulate heart rate is epinephrine, the brother of norepinephrine, comes from the adrenal medullus, a hormone. Thyroxine can. We already said neurotransmitters, acetylcholine and norepinephrine. Electrolytes can do it, calcium and potassium. Other things can do it are age. The heart generally kind of slows down a little bit as you age, but not necessarily. Gender, some will say females have a faster heart rate than males. Casual association. Exercise, particularly aerobic exercise, running, swimming, can make the person have a stronger heart. So a 26-mile marathoner has such a strong heart, he doesn't have to have such a fast beat. So you remember, normal heart rate was 60 to 100. His heart rate, or her heart rate, may be a 55, and that's normal because of the fact of how strong it is. So they do more per beat, more stroke volume. Body temperature, as it increases, generally will increase heart rate, and the cooler it is will slightly decrease heart rate. Okay, when it comes to control of heart rate, the sensory side are baroreceptors and chemoreceptors. The baroreceptors that we have are stretch receptors in blood vessel walls. The stretch receptors are in the carotid stretch receptors, and the aortic. Then we have another stretch receptor that's generally in the right atrial area. Okay, they will speak of. Now, the baroreceptors are the main controllers. However, chemoreceptors also. Chemoreceptors, we have what we call bodies and a central chemoreceptor. Now, they have an influence on heart. They have an influence on blood vessels. But I won't say much on them because I'm going to really heavily talk on those when we get into respiratory. That's where they are number one as a controller. But as far as in the blood vessels and heart, the baroreceptors are. So let's go and talk on how the baroreceptors would work. All right. What happens is this. The carotid baroreceptors, they are afferent, their sensory nerve going is coming from cranial nerve 9, known as the glossopharyngeal. So cranial nerve 9 sends a signal to the cardiac acceleratory center and the cardiac inhibitory center in the brain. To the cardiac acceleratory and cardiac inhibitory center in the brain. The aortic comes via the sensory 10. It too sends it to the cardiac acceleratory and cardiac inhibitory in the brain in the medulla oblongata. The right atrial pressure receptor does 10 also, and it sends it to the cardiac acceleratory and cardiac inhibitory center. So we set the stage for the sensory fibers. All right, now let's see how this works. All right. As we look at, though, this, I'm going to come to this here. This is in the blood vessel chapter PowerPoints. But I want to show you, here's cardiac output to heart, that the ultimate reason for this heart action is to maintain a normal blood pressure. Okay? So if cardiac output goes up, blood pressure could go up. Cardiac output goes down. Now, I won't speak on this because this has to do with the blood vessels. But I want you to concentrate on cardiac output and blood pressure as you understand this. Now, the other thing I want you to concentrate on, let's think of a water hose. If there's an increased pressure in the water hose, it will push against the walls of the water hose, causing the walls to get tight, tension. See, when you think about high blood pressure, what do we really call it? Hypertension. It's not so much the blood pressure, the fact the blood pressure pushes pressure against the wall, the tension, tries to stretch them out. and could cause them to form a pocket known as an aneurysm or to actually burst. So I want you to see the relationship between cardiac output and blood pressure. All right, so let's go back with that in mind. That means if there's increased stretch, tension on the wall of the carotids, it would mean that the blood pressure is too high there. The signal would go into through the glossopharyngeal, cranial nerve 9, to the cardiac acceleratory and cardiac inhibitory. It would want the heart to decrease its action. What nervous system? Parasympathetic. What neurotransmitter? Acetylcholine. What receptor? Muscarinic. So this action then would go to the heart. It would slow down the SA node, and also decrease the action of the sympathetic. So the sympathetic would decrease, which would decrease contractility. So cardiac output would go down. If cardiac output goes down, blood pressure goes down, which then would restore the wall back to the normal stretch. If it's too little stretch, then the opposite would occur. You would send the signal in, it would affect the cardiac acceleratory. Cardiac acceleratory would work via the sympathetic, sending out norepinephrine, which ultimately would go to beta-1 receptors on the heart and increase heart rate and contractility. And like I said, the aortic would do the same thing. Too much stretch, do the same thing. Too little stretch, do the same thing. Now we come to the atrial pressure receptor. The atrial pressure receptor, right atrium, is on the right side of the heart. If you had too much venous return into the right atrium, now read this in the textbook, too much venous return and not enough exit. Too much return and not enough exit. The only way for that to clear is to clear through the heart because you're on the right side. See, all these others were on the left side of the heart if you look at it and study it. So in this case, too much stretch, you want to increase heart activity. You want to increase, which would mean you'd send the signal in via the vagus, but you want to activate the cardiac acceleratory, hitting with norepinephrine to try to increase. That particular activity, if you look in your book, is called the Bainbridge Reflex. The Bainbridge, Bainbridge Reflex. So this gives you an idea. I also am putting a video in that, another video motion type that you can look at to get an idea of this further. So everything I'm trying to add a video motion one to help you with this activity. All right. Thank you there.